Hello, ladies and gentlemen. We are now looking at radian measure. Now, angle theta in terms of radian measure is equal to the length of the arc of the circle divided by the length of the radius. So here's what we have. Angle theta, this is called angle theta. Angle theta is equal to the length of the intercepted arc. And let me label this as well. So here in this case, we have arc A, B. Yeah, let me label that so we can have something to refer to. So in this case, we are looking at arc AB. Let me lock that in so it doesn't move. Lock this in so that doesn't move. So now we're looking at arc AB. So that's our intercepted arc. So angle theta, in terms of radians, is equal to the length of arc AB, whatever that is, divided by the length of the radius. So once again, angle theta, in terms of radians, is equal to the length of the intercepted arc divided by the radius. So please remember this formula, and we will see its use very shortly now, in a few moments. Now, angle theta is also known as the central angle in this case. So in this case, the angle that we see listed here, this is known as the central angle. So that's the different parts of this. So we have arc AB. Angle theta is known as the central angle. And when we're looking at angle theta in terms of radians and not degrees, that angle is listed as the length of the intercepted arc divided by the radius. In this case, our intercepted arc is AB. So, now one rotation, when we do one rotation, that is the circumference of the circle, which is 2 pi r. Now in this case, that is the length of the measure around the circle. So now remember, in order to determine the measure of angle theta in radians, we're going to take this arc length, which is 2 pi r, which is the circumference, the measure around the circle. We divide that by r. So in this case, the measure of angle theta in terms of radians is 2 pi radians, because the radius, they cancel one another. They divide out. So one full rotation around the circle, that's the equivalent of 2 pi radians. Now, 1/2 a rotation. If we just multiply both sides of that equation for one rotation equaling 2 pi, we multiply both sides of that equation by 1/2. And in this case, 1/2 a rotation is equal to pi radians. That's half a circle. So 1/2 a rotation. We multiply that times 2 pi radians, because we're going to take half the circle, and that is equal to pi radians. Now 1/4 of a rotation, again, we multiply 1/4 times 2 pi radians. That's equal to pi over 2 radians. 1/6 of a rotation, we multiply 1/6 times 2 pi, and that gives us pi over 3 radians. So that would be the measure of that angle. So to summarize again, 2 pi radians, that's equal to 1 complete rotation. 360 degrees is equal to 1 complete rotation. So now we know that 2 pi radians is the equivalent of 360 degrees. Now this is important because we're going to use this relationship. So please, if you need to, I ask you to pause the video and copy these notes, because you will need them. So now we here divided both sides by 360, and we simplified this, and now we know here that in terms of radians, 1 degree is equal to pi over 180 radians. So 1 degree is equal to pi over 180 radians. Now, beginning with the equation again, that 2 pi radians, since that's one complete rotation, that's equal to 360 degrees, because that's one complete rotation. Now to determine how many degrees 1 radian is equal to, we divide both sides of that equation by 2 pi. The 2 pi's divide out, and we now know that 1 radian is equal to 180 degrees divided by pi. So this is the measurement of 1 radian. 1 radian is equal to 180 degrees by pi. So you'll need to also know this formula. So I suggest that you pause this video, copy these notes, because you'll be using them a little later on. Now, we want to convert from degree measure to radian measure. So whenever we want to convert from degree measure to radian, notice the angle or the measurement that we want to convert from always goes in our denominator. So I want to convert from degrees to radians. So this is represented as pi radians over 180 degrees. This allows us to take an angle and convert it from degrees to radians. Now, whenever we want to convert from radian measure to degree measure, our ratio is now 180 degrees over pi radians. So whenever we have something in radians and we want to convert it from radians to degrees, we're going to use the ratio of 180 degrees divided by pi radians. So again, please pause your video, take your notes because you will need this as we move on. Ladies and gentlemen, this concludes part 3, the introduction of converting from degree measure to radian measure and from radian measure to degree measure. So please continue on to part 4. Once again, this is your teacher and your instructor, Mr. Joshua Davis. Please have an outstanding and fabulous day.